we're Team 3, and we're doing the power design for Design 2. So for our power system, kind of the design here was we'll be using manual force to operate a lever, which will go through a system of gears to turn the barrel crusher that the crusher part of our team will be explaining, I think, next. We will be using gear ratio to reduce the amount of manual labor put in, as well as allow for comfortable positioning of where the lever will actually go, or the handle for the crane. And then we will have the handle be able to be detached so you can replace it with a wheel to either hook up to a bike through a system of pulleys or whatever, or hook a gas motor up to it, or basically have it to where you can change your input of the power.
So a couple of the assumptions that we have, one would be that we want it to be powered by one person if possible, so we can make it as easy as possible for whoever would be powering it, if it's like women or younger people over there. And then we also want it to be able to mount to the sidewall of the frame. And we also want the gear reduction system. We want a gear on the actual crushing rolling barrel.
Alright, so a couple of unknowns that we have right now are just the torque required to crush the rock, and that depends on the size of the barrel, and also depends on the rock type. So that's just one thing we need to figure out. Comfortable crank diameter, so how big you need to have the diameter of the crank turning for different people to use it, so that way it's easier to use. You also need to work on the gear ratio for the ideal torque, so if you have a bigger gear rotating a smaller gear, if it would help make it easier to turn the wheel, kind of like on a bike. If you change your gears and you go up a hill, it's easier to pump, but you're moving slower, kind of a thing. And then we also need to work on a couple of the other unknowns are the size of the barrel itself, so the final gear, how big that would need to be, and the method of attaching it to the frame. So that's just
Should be able to. Well, this was a video.
Says in the plane.
Oh, yeah, it does. All right. Well, I can kind of explain the motion. Basically, the handle will rotate like this. That will operate through the gears, and then the barrel, which will be crushing the actual rock, will be rotating right now in the opposite direction. We may change that in the future of the handle rotation, but wouldn't be a one-to-one because of the gear reduction system. But yeah.
So, thing learned from the mock-up. First, how gears will work together to reduce the force needed by the operator. Also, the importance of gear ratio to make an adjustment for the speed and the torque applied. Also, we need to be aware of how the handle attached to make sure it will work clear together the other gears.
Any questions?
One question is so how much power do you expect one person can generate?
We hadn't looked into that. Here's the video. We'll play this for you real quick. Should work. Why not? All right. Well, sorry. It was working. I don't know what the problem is now. But we didn't know. We tried looking up some different torque values for what would be easy for a human to operate and stuff. And it just kind of depend on. There's a lot of factors going into it in terms of the actual length of the handle. Farther out you are from the center of the wheel and everything. But we're definitely going to look into that moving forward to make sure that it's something that is comfortable and easy to use for a wide array of people.
We are trying to control gears so we can make it work with the lowest force we can apply.
So single person, one person can just up.
I'm guessing that maybe we can think about if we can have multiple persons inputting power simultaneously.
Yeah, we could easily have something on the other side that's hooked up to a almost identical mirrored system, and the cranks would be synced up because they're hooked onto the main barrel, and then you could have two people on either side of the machine doing the same motion to help drive it to make it easier. But that's just an option.
Yeah, so that crane attaches to like a sub gear, and then there's actually like internal gear on the barrel. Is that how you said it was?
Say that again.
So there's like an internal gear on that barrel, and then there's a sub gear on the handle. Is that how you have it right now?
Basically, this handle will attach to this gear in some way, shape, or form. We haven't planned that out yet, which will connect to this gear, and then depending on how we do it, the mock-up here was just kind of a proof of concept type thing. So the goal is to have this gear itself be fully attached to the barrel and have it just kind of sit and rest in the frame somehow. We have to obviously discuss that with our frame team and our power team. But then it would just transfer straight through from the handle to the gear, and then the final gear would be directly connected to the barrel. That kind of answer your question?
Yeah.
Okay. Again, apologies for not having the video. I downloaded it afterwards to make sure it worked, and it worked on my computer, but I don't know what the problem is, so we can send that too if they would like to look at it.
Sure.
I can send that to you or upload it to Slack or something.
Okay, that would be good. Thank you.
Thank you.